Hi, we are the Group 1.
My name is Mariel P. Pedrosa.
I am Starlichan J. Inclunar.
I'm Kristen May Pavilion.
I'm Jitonji Chacamos.
And we are going to present the engineering materials in metals and metalloids.
We in the modern world are surrounded with elements that are greatly used and are beneficial to us people. Engineering materials play a vital role in our day-to-day life. We use a variety of metals and non-metals such as iron, steel, aluminum, copper, zinc, lead, tin, glass, rubber, wood, plastic, etc. in automobile industries. Metal, ferrous, and non-ferrous play a vital role and are extensively used in manufacturing industries because of their excellent mechanical properties.
However, metal alloys, a metal made by combining two or more metallic elements, especially to give greater strength or resistance to corrosion, are made using several methods such as adding the element to the base metal in a furnace or by hot process in which the metal and elements are sandwiched and pressed to form an alloy. So, the alloys have many applications in engineering in which high temperature, low corrosiveness, toughness, and the durability are required.
Metals and metalloids take a great part of today's modern world and are mostly used almost in everything. And today, we are talking about the engineering materials, what important metals or metalloids are used in engineering and how it is used in the industry. But since we all know that engineering is the use of scientific principles to design and build machines, structures, and other items, including bridges, tunnels, roads, vehicles, and buildings, now, let us get to know what metals and metalloids are.
The metals which exhibit the highest degree of metallic behavior is known as metals. Metals are placed on the left side of the periodic table. Metals have a shiny appearance. Thermal and electrical conductivity is high in metals. Metals have a low electronegativity. Metals show ductility and malleability. Lithium, sodium, calcium, magnesium, barium, lead, indium, bismuth, iron, copper, zinc, nickel, and etc. are the examples of metals. Metalloids are such elements which possess some of the properties like metal, while some are like non-metal. Metalloids are placed in the middle of the periodic table. Metalloids have a shiny and dull appearance. Thermal and electrical conductivity is good, though it is less than metals. Metalloids neither possess a too high or too low value of electronegativity. Metalloids also do not show this property. Arsenic, tellurium, antimony, polonium, tinese, etc. are the examples of metalloids.
Going deeper, let us know the list of metals used in industries or industrial engineering. Common engineering metals include aluminum, chromium, copper, iron, magnesium, nickel, titanium, zinc, and silicon. These metals are often used as alloys, with the noted exception of silicon. Most effort has been placed on understanding the iron-carbon alloy system, which includes steels and cast irons.
Carbon steel. Carbon steels are basically just mixtures of iron and carbon. They may contain small amounts of other elements, but carbon is the primary alloying ingredient. The effect of adding carbon is an increase in strength and hardness. Most carbon steels are plain carbon steels, of which there are several types. Low carbon steel. Low carbon steel has less than about 0.30% carbon. It is characterized by low strength but high ductility. Some strengthening can be achieved through cold working, but it does not respond well to heat treatment. Low carbon steel is very weldable and is inexpensive to produce. Common uses for low carbon steel include wire, structural shapes, machine parts, and sheet metal. Medium carbon steel. Medium carbon steel contains between about 0.30% to 0.70% carbon. It can be heat treated to increase strength, especially with the higher carbon contents. Medium carbon steel is frequently used for axles, gears, shafts, and machine parts. High carbon steel. High carbon steel contains about 0.70% to 1.40% carbon. It has high strength but low ductility. Common uses include drills, cutting tools, knives, and springs.
Low alloy steel. Low alloy steels, also commonly called alloy steels, contains less than about 8% total alloying ingredients. Alloy steels are typically stronger than carbon steels and have better corrosion resistance. Tool steel. Tool steels are primarily used to make tooling for use in manufacturing, for example, cutting tools, drill bits, punches, dies, and chisels. Alloying elements are typically chosen to optimize hardness, wear resistance, and toughness. Stainless steel. Stainless steels have good corrosion resistance, mostly due to the addition of chromium as an alloying ingredient. Cast iron. Cast iron is a ferrous alloy containing high levels of carbon, generally greater than 2%. The carbon present in the cast iron can take the form of graphite or carbide. Cast irons have low melting temperature, which makes them well suited to casting.
Gray cast iron. Gray cast iron is the most common type. The carbon is in the form of graphite flakes. Gray cast iron is a brittle material and its compressive strength is much higher than its tensile strength. The fracture surface of a gray cast iron is a gray color, which is how it got its name. Ductile cast iron or nodular cast iron. The addition of magnesium to gray cast iron improves the ductility of the material. The resulting material is called nodular cast iron because the magnesium causes the graphite flakes to form into spherical nodules. It is also called ductile cast iron. Nodular cast iron has a good strength, ductility, and machinability. Common uses include crankshafts, gears, pump bodies, valves, and machine parts. White cast iron. White cast iron has carbon in the form of carbide, which makes the material hard, brittle, and difficult to machine. White cast iron is primarily used for wear-resisting components as well as for the production of malleable cast iron. Malleable cast iron. Malleable cast iron is produced by heat treating white cast iron. The heat treatment improves the ductility of the material while maintaining its high strength.
Aluminum alloys. Pure aluminum is soft and weak, but it can be alloyed to increase strength. Pure aluminum has good corrosion resistance due to an oxide coating that forms over the material and prevents oxidation. Alloying the aluminum tends to reduce its corrosion resistance. Aluminum is widely used material, particularly in aerospace industry, due to its lightweight and corrosion resistance. Despite the fact that aluminum alloys are generally not as strong as steels, they nevertheless have a good strength-to-weight ratio. Nickel alloys. Nickel alloys have high temperature and corrosion resistance. Common alloying ingredients include copper, chromium, and iron. Copper alloys. Copper alloys are generally characterized as being electrically conductive, having good corrosion resistance, and being relatively easy to form and cast. While they are a useful engineering material, copper alloys are also very attractive and commonly used in decorative applications. Copper alloys primarily consist of brasses and bronzes. Titanium alloys. Titanium alloys are light, strong, and have high corrosion resistance. Their density is much lower than steel, and their strength-to-weight ratio is excellent. For this reason, titanium alloys are used fairly commonly, especially in the aerospace industry. One primary downside of titanium alloys is the high cost.
A summary of our report. Common engineering metals include aluminum, chromium, copper, iron, magnesium, nickel, titanium, zinc, and silicon. These metals are most often used as alloys. Metal alloys are made by combining two or more metallic elements, especially to give greater strength or resistance to corrosion. The alloys have many applications in engineering in which high temperature, low corrosiveness, toughness, and durability are required. Some examples of metal alloys are carbon steel, low carbon steel, medium carbon steel, high carbon steel, low alloy steel, tool steel, stainless steel, cast iron, gray cast iron, ductile cast iron, white cast iron, malleable cast iron, aluminum alloys, nickel alloys, copper alloys, and titanium alloys.
This is the end of our video.
Thank you for watching!